Hello, ladies and gentlemen. Hopefully everyone is doing well today. Today we are going to continue working on stoichiometry. So we are going to start something somewhat new, but very similar to what we've been doing before. Previously in the class, we have been solving for stoichiometric questions, or we've been trying to solve questions that have only dealt with us going from grams to grams. So we've only been going from, whoops, let's make that a little bit bigger here. We've been going from grams to grams. And we went from grams to grams. If we started at grams, we went 1 street, 2 streets, 3 streets to get there. Remember, the street is also called a conversion factor. So the first conversion factor would be molar mass. The second conversion factor would be the mole ratio. And the third conversion factor, or the third street, would be called molar mass. And so we've worked that out, and everybody has a pretty good idea about how to figure those things out. But today, we're going to take a different journey. So instead of going from grams to grams today our question is going to take us to different points of our mole maps. So I'm just going to start you off by giving this example to you, which is going to be on every one of your handouts, and showing you how this example works. Now you can see how this example is color coded. So you can see that we have this color green matches with that color green, and then this green with this green, the purple with the purple, the red with the red, oops, wrong red line, with the red, and then the orange with the orange. Now, ladies and gentlemen, I'm going to walk you through that process. There's a couple of things that we have to do always when we read the question. Figure out where we're starting and figure out where we're ending. You can see everything I've done so far. So this question says that you have 5 grams of hydrogen gas. That would be right here, this reactant. And it's going to react with excess nitrogen, which means that we have all the nitrogen we need. We don't need to worry about it. And the question is, how many liters of this NH3 are we coming up with? So we're looking for liters of NH3. So if we start this question off, we have 5 grams of hydrogen. We're going to start here. So this map up here, this whole map here belongs to hydrogen. And we're looking for the number of liters of ammonia. So this whole map over here is ammonia. And the bridge to get from one map or one city to the other is by connecting the moles through this mole ratio. But I'm going to erase all that and we'll start over. So we're starting off with 5 grams of hydrogen, which means we're going to start with grams. 5 grams of hydrogen. And we're going to look for liters of ammonia gas. Now I put a little balloon up here. You guys see this little balloon? That's to show you we're talking about gas when we're talking about liters. This liters over here, we're working with liquid liters, all right, or solutions. And so, but today we'll be working with gases, which we've worked with before, but we haven't worked between different compounds before. We've only been working with one compound. So it says that we have to go to NH3 and we're going to find the number of liters. Let me put that in orange. Okay. So we're looking for the number of liters, ladies and gentlemen. What are we given? We're given the number of grams of hydrogen gas. So we can clearly see, hopefully, that we're going to start off at 5 grams. And that's going to be, oops, I don't want that one. Let's go back to just drawing a straight line. That's this one here. We're going to go, ladies and gentlemen, right here, and we're going to start with 5 grams of hydrogen gas. Then what are we going to do? Well, to get from hydrogen gas to grams, and then to move out of this grams, we're going to follow this track right here. And that is going to be the molar mass. I think I used the wrong color, green, but it's okay. And so this molar mass, ladies and gentlemen, this conversion factor right here is the same as this. So this first conversion factor here is going to be the molar mass. That's going to lead us. So now we're sitting at moles, and we want to move from hydrogen moles all the way over to this NH3 ammonia moles. And to do that, we're going to move through the mole ratio. Remember, this mole ratio conversion factor is going to use, and I'll put it here. I've asked kids, I go into these little rooms and talk to you, and kids are like, yeah, I don't really remember where these numbers come from, but it says it right below. It says that the numbers that we're going to use come from the balanced chemical equation. So we're going to use the number 3 and the number 2. And you can see that this conversion factor right here correlates directly to this purple line, getting us from moles of hydrogen, again, moles of hydrogen up here, all the way across to moles of ammonia. Once we get to this moles of ammonia, we know that we want to go up to get to liters. So we're going to move up this line here, and the conversion factor that is that line or that street is going to be right here in our mathematical equation, right? And so that is going to be our molar volume, and that molar volume will get put in. And then finally, that gives us our answer, which this answer, which is in orange, is going to be right there. And it's just automatically going to pop up when we multiply. Now, kids are still, some students are struggling a little bit. They're not sure why we put certain things in the top of or the bottom, but just as a reminder, we start off with this 5 grams of hydrogen, and our purpose is to cancel out the words. So we cancel out grams of hydrogen with grams of hydrogen. And that's how we know to put grams of hydrogen on the bottom. At this point, we'd be working with moles of hydrogen. We want to cancel moles of hydrogen with moles of hydrogen. So moles of hydrogen is going to cancel. Now we're at moles of ammonia. We don't want moles of ammonia. We want to get to liters. So we're going to multiply by the molar volume. We're going to put moles on the bottom down here so that the moles cancel. At this point, the only thing we have left is liters of ammonia. And lucky for us, that's exactly what we want to get, is liters of ammonia. So we're going to be putting this in the computer just like it looks. And that answer is just going to magically pop up on your calculator. So lucky you. You don't even have to understand how the numbers work. I hope you do, that you understand that these are all just fractions. We multiply the numerator and we're dividing by the denominator, but calculator, I guess, is taking care of all that nowadays. So, ladies and gentlemen, that is what I'm going to show you in just a few seconds. So let's take a look and scroll on down. And I'm going to show you this first example right here. So here we go. All right, so here's our example that we're going to work on this afternoon or this morning. So what we're going to do, the first thing we always want to do is read our question. So let's go through and let's read the question. So the question says, how many liters of oxygen? So we're looking for liters of oxygen. So this is oxygen right here. So we're looking for how many liters are produced when 75 grams of trinitrogen pentaoxide, this N3O5, decompose. So this is the N3O5, and we're starting with 75 grams of this stuff. So we're starting with 75 grams of this trinitrogen pentaoxide. Don't be scared, it's just a formula. So we understand now that we're always going to go from left to right. So this side up here is going to be N3O5. So this entire map right here is N3O5. This other side is going to be oxygen, and that's O2 oxygen. So this whole map right here is going to be oxygen. Now, the question is, how are we going to get there? Well, I'm going to just ask some questions. I'm going to number this one 1, 2, 3, 4, 5. That's a 4 right here. Don't be scared. It looked like a 7. 4, 5, 6, 7, 8, and 9. And my question is, with this N3O5, where are we going to start? What number will we start with, ladies and gentlemen? That's right. We're going to start with grams, ladies and gentlemen. We're going to start with grams. 75 grams of this N3O5 compound, and it would be number 8. And now let's take a look again. Where are we going to go? I'll keep this one going. So that would be 9. Let's say that's 10, 11, 12. Well, this thing is 13, 14, 15, 16, 17, and 18. Ladies and gentlemen, this one here is 10. This one here is 11. All right, 12, 13, 14. That's a 14. My pen seems to be glitching a little bit. So my question is, where are we going to end up, ladies and gentlemen? What number will we end up with on the oxygen side? That's right, ladies and gentlemen. We're going to end up with number 10. Okay, so we're going to end up here with number 10 because we're looking for liters of oxygen gas. Now, I'm going to delete all of this for us so that we can kind of start this over. But before we do, let's take a quick look at how many streets or how many conversion factors it's going to take. So let's take a look. We need to get from grams all the way up here to liters. And it's going to take 3 streets. I don't want that. Let's go back to my pen. It's going to take 1 street to get from grams to moles. 2 streets. So this is going to be our second conversion factor. And then our third conversion factor. So we need 3 conversion factors. But right now, since we know that, what we need to do is scroll down our page. This is just like what your homework looks like. And we're going to grab the conversion factor that has 3, or the dimensional analysis that has 3 conversion factors. We're going to scroll back up to where we have to be. We're going to paste this right in. Control paste. And now we can start working on our problem. So we are going to be starting at, we are going to be starting at the mass, and we are going to be ending up at the volume. So this is where we're going to end up. Okay, so what are we going to do first? Well, what are we given, ladies and gentlemen? We are given how many grams of this trinitrogen pentaoxide? That's right, we're given 75 grams of this N3O5. This N3O5. Okay, and then we're going to say, well, what are we looking for? Well, we're looking for liters. Liters of what? Well, let me write that in for us so that we can have that in, because it is easier when we write it in. This would be oxygen over here, right? And then over here is going to be, whoops, not C, it's going to be N. Let me delete that really fast. There we go. It's going to be N3O5. So we're going to write in what we're going to. So we're looking for liters of oxygen. Oops. We're looking for liters of oxygen gas. Right? And at this point, now we just have to figure out what's our next conversion factor. So what conversion factor is going to come right here in this space? What conversion factor is going to come right here, this first conversion factor, ladies and gentlemen? That's right, it's going to be molar mass. The first thing we're going to do is we're going to take the molar mass, and we need to find the molar mass of this N3O5 compound. So to do that, we need to go get a periodic table. So we're going to go into Canvas. And once we get into Canvas, you're going to come down to our resources. You're going to click on the periodic table, and we're going to look up how much does nitrogen's mass? How much is the mass of nitrogen? 14.01. We have 3 of those. And we have oxygen, which is 16, and we have 5 of those. So let's get a calculator out and multiply that. So I'm going to come back to my home page, and I'm going to grab a calculator. I'm going to drag it out of here so that I can use it, and so you can see it as I'm working on it. There we go. Oopsie daisy. Oh, geez. Where'd my calculator go? There's my decimals calculator. All right, so let's put that in. We want to know the mass of N3O5. So we know we have 3 nitrogens. So I'm going to put parentheses, each weighing 14.01. And we want to add that to 5 oxygens. So 5 times 16. Okay. And when we multiply that out, it's going to be 122.03. Now, again, that's 122.03 grams per mole. So this will be for N3O5, it's going to be 122.03 grams of N3O5 for every 1 mole of N3O5. Or, ladies and gentlemen, are we going to have 1 mole? My pen is really glitchy on me. All right, or are we going to have 1 mole of N3O5 for every 122.03 grams? So which one of those are we going to use? Are we going to use A, or are we going to use B in this situation right here? Remember, we want to cancel out the grams. So what are we going to do? We're going to slide on down here, and we're going to put grams on the bottom. All right, so I'm going to copy that just to save me some time. So we're going to have grams. How many grams? 122.03 for every 1 mole of this substance. Okay, so at this point, we've canceled out the grams, and we're at 1 mole of N3O5. We're sitting right here. What's going to be the name of this central conversion factor, ladies and gentlemen? What's the name of this conversion factor right here? What's the name of that conversion factor right there? That's right, ladies and gentlemen. We're going to call it the mole ratio. And the mole ratio is going to come from the balanced chemical equation, right? So we're working with N3O5, and we're working with oxygen. At this point, we want to cancel out the N3O5. So we're going to put the N3O5 in the denominator, or on the bottom of this conversion factor. Okay, so I'm going to cancel out moles of N3O5. How many moles of N3O5? We'll get the number from the conversion factor. It's going to be 4. And we're going to go from moles of N3O5 over to moles of oxygen. And we have 7 moles of O2 of oxygen. All right. And so at this point, ladies and gentlemen, we just made this bridge. We just bridged this gap between moles and moles, right? What have we canceled out? We canceled out moles of N3O5 with moles of N3O5, grams of N3O5 with grams of N3O5. And if you take a look, we just landed right here at moles, and we are at moles of oxygen, which is right where we should be, moles of oxygen. But we have one last street to take. It's a red street. What is the name of this conversion factor, this street? What's the name of that street or that conversion factor, ladies and gentlemen? That's right, it's going to be molar volume. What is the conversion factor for molar volume? Well, it's going to be, it says it right there, 22.4 liters for every 1 mole, okay, for oxygen. Or it's going to be 1 mole of oxygen for every 22.4 liters. writing a little slower so that it doesn't glitch out. So my question is, which one of these are we going to do? Are we going to do conversion factor A or conversion factor B? Remember, we're trying to cancel out moles of oxygen. Trying to cancel out moles of oxygen. All right. So which one are we going to use? Let me get my pen back. That's right, ladies and gentlemen. We are going to use conversion factor A so we can cancel out moles of oxygen. So for every 1 mole of oxygen, we're going to have 22.4 liters of oxygen at STP. Okay. So, oh, and it should say, and I will change that in, when it decomposes at STP, okay? Because we talked before that it has to be at standard temperature pressure in order to use this number 22.4, right? So how are we going to solve this problem? Well, we can see that the moles of oxygen is canceled out. Whoops. We can see that the moles of oxygen is canceled out, leaving us with only liters of oxygen, which is exactly what we wanted. So let's come on over and let's get the this calculator and let's work it out. So we have, let's put it in just like it looks. So we're going to have 75, and then we're going to have 3 sets of parentheses, right? Those are my 3 sets of parentheses. 1, 2, 3, 1, 2, 3. The first set of parentheses, it's going to be 1 over 122.03. This middle conversion factor, it's going to be 7 over 4. And in this third conversion factor, it's going to be 22.4 over 1. Now, I know some of you are still struggling on using the calculator and understanding how to put parentheses in and stuff, but the more you work on that, the better it's going to be. So our answer is going to be 24.09. So let's put it in, 24.09. Ladies and gentlemen, this is our answer. So, oops, it should be an orange. This is going to be our final answer right there, 24.09. So if you have any questions, I will be sitting right here to work with you. Let me know if you need anything, and if you do, I will be there in a jiffy.